Hi everyone, this video is to help you learn about rotations of polar graphs. So tonight's homework is it's actually a packet, so make sure you pick that up today. See if you know these SpongeBob trivia questions, but you'll have to have your teacher tell you the answers in class. Okay, so today we are going to be talking about rotating polar graphs. We're going to start with a line and then we'll move on to circles. I won't do all of the problems in the packet with you because there won't be time in the video, so you'll just want to go back and revisit some of them as we go through. And I'm going to go kind of fast because you should know how to graph it, so if you need to, pause the video to stop it and graph for yourself before you see what I've done. So first thing we're doing is we're graphing the line r cosine theta equals 4. So let me rewrite what that is. That's actually the equation x equals 4. So here's our graph of that. So now we want to turn this graph. We're going to turn it like 90 degrees, but we want to figure out which direction it's turning. This is going to be a rotation of this original line. So you can probably take a guess at which way it's going to go because it's pi over 2. You've kind of got a 50-50 chance, but I'm going to show you the algebra behind this. So we're going to go ahead and use a cosine subtraction formula to extend this out and then do some substitution. Oops, my stylus is not working as good as it could, but we'll get there. So here is my cosine subtraction formula. I'm going to go ahead and distribute the r. So I now have r cosine theta cosine of pi over 2 plus r sine theta Yep, the stylus needs a new tip here. Sine of pi over 2. This all equals 4. Well, I know that cosine of pi over 2 is 0, so this whole part is 0. And then sine of pi over 2 is 1, and this is y. So I have 1y equals 4. So that means this line rotated to y equals pi over 4. That rotation, so think about this being like a steering wheel, like this fourth circle is a steering wheel, and you are keeping the line x equals 4 on the steering wheel. It's like your hand, and you're turning the steering wheel so that your hand is now up at the top here. So we turned that would be considered counterclockwise. So we turned this line 90 degrees counterclockwise. Okay, so keeping that in mind, think about if we were to rotate this. So it started off same as before as r cosine theta equals 4. So ignore the rotation part. That's where it started. That is this line. And now we have this angle that we are rotating it. And so when we turn this thing, it will actually turn pi over 3 again counterclockwise. So let me get a new color here. And so here's pi over 3 line right here. Keeping your hand on the steering wheel, you're going to move the line along that fourth circle to the pi over 3 angle. So I said pi over 4, I'm sorry. And we're going to draw a line so that the line is tangent to that fourth circle at the pi over 3 angle. Now, if you wanted to do the algebra behind this, you would have to, again, know your cosine subtraction formula. And then obviously you have to know your trig rules. Okay, so we have r cosine theta when I distribute, so that's x, and cosine of pi over 3 is a half, so I have 1/2 x from the first part. Distribute the r into the second part of the parentheses, I have r sine theta, that's y, and sine of pi over 3 is root 3 over 2. And if I wanted to write this in a way that looks like what I'm used to, I would probably multiply by 2. So thinking like y equals mx plus b, right? So this becomes y equals negative 1 over root 3x plus 8 over root 3 which 8 over root 3, think about this being about a little bit less than 2. So when I divide by a little bit less than 2, I should get something 8 divided by a little bit less than 2 would be bigger than 4. So that looks not too bad there. And my slope is negative. It's a falling slope. And actually, this slope right here, this negative 1 over root 3, is actually the opposite reciprocal as the slope of this line. And the slope of pi over 3 is equal to the tangent of pi over 3. And the tangent of pi over 3 is root 3. And those two lines are perpendicular, that red one and the green one. So the slope of the red line there is the opposite reciprocal of that green one. Okay, so hopefully you can conclude that if you have an angle minus, so theta minus an angle, I guess I should have said it like that. This would be a counterclockwise rotation. And if you have an angle then theta plus an angle, then I hope it makes sense. It's going to go the other direction, which is clockwise. This is true if you're graphing a line or if you are graphing a circle. So here we now have a circle. This is the circle that is centered above the origin. So this equation here in rectangular, there's my center, will be x squared plus y minus 2 squared equals 4. Okay, so now I want to think about rotating this circle, and we've got it going pi over 4, but a plus. So we said that's a clockwise rotation, so it should turn, actually I think I have it graphed below, but it should turn 45 degrees clockwise. So let me uncover it. So there it is. The blue one is the rotation of the red one. The center of the blue circle is on the same circle that the original one was. So it's like we took, again, this is my center point. It's like I took it and I turned it 45 degrees. So there is where my new center is at. It's right there. If you can figure out what that is by hand or by looking at it, because you know a little bit about trigonometry, then you can just use that point. Otherwise, you're going to have to expand your sine addition formula. My colors keep changing them here. So I have 4 times sine theta cosine pi over 4 plus cosine theta sine of pi over 4. But I don't have enough going on here. I need another r on the right-hand side to be able to change it. So I'm going to multiply the whole entire equation by r. So now I have r squared on the left, and then I have 4r sine theta cosine of pi over 4 is root 2 over 2. And I have 4r cosine theta. And sine of pi over 4 is also root 2 over 2. R squared is x squared plus y squared. R sine theta is equal to y, and I'm going to divide the 4 by the 2. So I have 2 root 2y. And then this part becomes 2 root 2x. So now I get to do the fun stuff of completing the square. So I have x squared minus 2 root 2x plus y squared minus 2 root 2y all equals 0. And I'm going to complete this square. I'm taking half of 2 root 2, which is 2. Sorry, is root 2. Okay, so half is root 2. Root 2 squared is 2, so plus 2 plus 2. Half again of 2 root 2 is root 2. Squared is 2. Add it to both sides. I get 4. That 4 shouldn't be a surprise. You shouldn't even have to worry about that because the original circle's radius was a 4. So our new guy is going to be a radius of 4. Okay, so here is the center point. That point is at root 2 comma root 2. And the way you could have known that, you could go back to what you learned on day 1 of this unit, which is to say that, hey, this circle, or this point right here, is on the second circle, so the radius is 2, and it's at the pi over 4 angle. So it has a radius of 2, and the angle is pi over 4. So in polar form, the point is this. So to turn it into rectangular, I would do 2 cosine pi over 4, 2 sine pi over 4. Okay, so now I want you to try, this one on your own. It says change it without, graph it without changing to rectangular, and then check your results by changing after you graph. So I'm just going to remind you that you want to start off with r equals 6 cosine theta as your original graph, and then try and do the rotation. Pause if you need to. Okay, so the original graph was this purple. I should have done my ink in purple. So my original graph is the purple one. Let's change it to purple. And then the new one here, we rotated it clockwise, pi over 3. So then if you want to find the center of this new circle, the center was originally at 1, 2, 3, 0. Okay, so there's where the original is at. It is now turning down to this spot. So when I turn it, get this set up here. First of all, I know that the radius is 3, so the answer is going to be 9 over here. This polar point down here would be at 3, that's my radius, 5 pi over 3, that's the angle. So I would do 3 times cosine of 5 pi over 3 for the x coordinate. So 3 times 5 pi over 3, cosine of 5 pi over 3. Cosine of 5 pi over 3 is a half. So we have 3 halves. And sine of 5, nope, that's right, sorry. Sine of 5 pi over 3 is negative root 3 over 2. So I'd have negative 3 root 3 over 2 as your center point. So x minus 3 over 2, x plus 3 root 3 over 2. Or you use the sine, that's cosine. You use the cosine addition of formula. Okay, let's see. Last one I need to talk about with you. So this one is a little different. It's not set up in the same way. So you're actually going to want to just figure out this graph all on its own by doing, by substituting stuff in first to graph it rectangularly, because it's kind of hard to tell what's going on. Do not do any subtraction. Just substitute everything in the way it looks. So I'm going to replace r squared with x squared plus y squared. I'm going to replace r cosine theta with x, and 16 is going to stay there. And the reason you don't want to change anything is because you actually don't have to complete the square if you put the 16 with the 8x. So this is actually x plus 4 squared plus y squared. Okay, so what's interesting about this circle equation, so there's my center, but my radius is not going to go through the origin or the pole anymore. So now I have a circle that in this case the radius is longer than where the center is at. So it's going to go past the origin. So I have a center at negative 1, 2, 3, 4. Of course, I made a circle that's going to go off my graph. So there's my circle. Not very pretty, but there it is. So now what you want to do is figure out what this is going to do. What is pi over 2 going to do to this picture? It's going to take this center point and it's going to rotate it. And since this is a minus inside, we're going to go counterclockwise, which is going to actually be like down in this case. So this point here is going to rotate pi over 2 down to that spot. So the circle, that's not very good either. So the circle is going to have a center right there. So that center is at 0, negative 4, but the radius is still 5. So it just moved it, but it didn't really change any of the information. So my rectangular equation would be 25 equals x squared plus y plus 4 squared. Okay, there's a few practice problems on the back I would like you to try on your own, and then make sure you ask if you have any questions.